Hi friends, this is Naresh. This is my 17th lecture on design of machine members 2 subject. This is unit number 2, design of IC engine parts. In this session, I will explain about function of a piston and its parts. Okay, this is the example diagram for a piston and its parts. This is the working animation of a piston in a cylinder. These are the parts list. This one is a cylinder. Okay, this one is a cylinder. This inside hole is called bore. Okay, bore of the cylinder, and this is a piston. Okay, these grooves are called oil grooves or compression grooves, and this one is a piston pin or gudgeon pin. This one is a connecting rod. This is a crankshaft. This is a crank web, and this is a complete crank mechanism. Okay, yeah, this is the cylinder wall. Okay, so these are the inlet and outlet walls. This one is a spark plug for SI engines or fuel injector for CI engines. Okay, this is a position of top dead center. This is the position of a bottom dead center, and this is a gap or a clearance. Okay, so here I will explain about what are the functions of piston parts. Okay, the piston is a disc. Okay, the piston is a disc which reciprocates within a cylinder. Okay, the piston motion is in a reciprocating motion. It reciprocates within the cylinder in upward and downward direction. Okay, in upward and downward direction for vertical engines, uh, forward and backward for horizontal engines. Okay, it is either moved by fluid or it moves the fluid which enters the cylinder. The main function of the piston of an internal combustion engine is to receive the impulse from the expanding gas and to transmit the energy to the crankshaft through the connecting rod. Okay, so this is a crankshaft and this is a connecting rod. This is a piston. This is a piston pin. Okay, the main function of this piston is to receive the impulse from expanding gases and to transmit the energy to the crankshaft. Okay, to the crankshaft through a connecting rod. Okay, so this is the main function of the piston. The piston must also disperse a large amount of heat from the combustion chamber to the cylinder walls. Okay, this means uh, here a combustion takes place here, so a large amount of heat produced in the cylinder. Okay, we need to cool the cylinder. Okay, so we need to transfer this heat into outside surroundings. So here this piston transfers the heat to the cylinder walls. That cylinder walls transfer the heat to the surrounding walls by using thermal conduction property. Okay, thermal conduction, here thermal means heat and conduction means transferring of heat from one solid surface to the another solid surface. Okay, these are the working animations of piston within a cylinder. Here, this is a cylinder. Okay, this is a cylinder. This is a crankcase. Here this is a crankshaft. This is a crankshaft. This okay, this is a crank web. Okay, here this is a connecting rod. This is a piston. Okay, the piston moves within a cylinder in upward and downward direction. Okay, this cylinder guides the piston. Okay, so this thickness is called cylinder wall thickness. Okay, here you can observe here this is a 90 degrees cross sectional view, but this is a 180 degrees cross sectional view, half sectional view. This is a quarter sectional view. Okay, here you can observe the clear movement or motion of a cylinder, motion of a piston within the cylinder. Yeah, these two are the inlet and outlet walls. Okay, so these here this is a piston head. Sorry, this is a cylinder head. So the inlet and outlet valves are operated by the cam and follower mechanism. Cam and follower mechanism. Okay. This is the another example for pistons. Piston. This is a multi-cylinder engine. In this multi-cylinder engine, we have five cylinders, five pistons. Okay. Here the motion of the crankshaft also in rotary motion, but here you can observe here the position of a piston in the cylinder. You have to observe the position of a piston in the cylinder. Okay, these are the piston. These are the cooling fins to cool the cylinder walls. Okay, this is the one type of piston arrangement. This one is the another type of piston arrangements. This is a crankshaft. This is also a multi-cylinder engine. In this multi-cylinder engine having four cylinders with four pistons. Okay, this is a crankshaft. Okay, these are the crank webs. This is a crankshaft. Okay. So this is the another shape of a another arrangement of a piston. Here we have more than 10 pistons. This is a high load capacity engines. This is the another arrangement of a piston and connecting rods. This is a crankshaft. This is a gear mechanism. This is a connecting rod. This one is a piston pins. Okay, the connecting rod is the intermediate member between the piston and the crankshaft. The primary function of the connecting rod is to transmit the push and pull forces from the piston pin to the crank pin. Thus, convert the reciprocating motion of the piston into rotary motion of the crank. This is the full arrangement of piston, crankshaft, piston, connecting rod, and inlet and outlet valves, cam and follower mechanisms. Okay. Here you can observe here all these arrangements. This is a crank, sorry, this is a cam and follower mechanism. Okay, this is a camshaft. This one also camshaft. These camshafts are used to operate the inlet and outlet valves. Okay, these are the inlet and outlet valves. Okay, these are inlet and outlet valves. These are the pistons and piston heads. These grooves are called piston rings, and these vertical members, these are called connecting rods. This is a crank web. Okay, this shaft is called a crankshaft. Okay, this is the working of IC engine parts in a cylinder. Okay, these all are arranged in cylinder. Here you can observe here this is a crankshaft. The crankshaft is used to convert reciprocating motion of the piston into the rotary motion of the crank. Okay, so the crankshaft consists of shaft parts which revolve in main bearings. The crank pins to which the big ends of the connecting rod are connected. The crank arms are crank webs, which connect the crank pins and shaft parts. The crankshaft, depending upon the position of the crank, may be divided into uh, two parts. That is a side crankshaft or overhang crankshaft. Another one is a center crankshaft. Okay, these are two are the types of crankshafts. Now the materials used for piston. The most commonly used materials for pistons of IC engines are cast iron, cast aluminum, forged aluminum, cast steel, and forged steel. So these are the materials used for making the pistons. For small engines, we are using cast aluminum, whereas for large, big engines, we are using cast iron. The cast iron pistons are used for moderately rated engines with piston speeds below 6 meters per second. And aluminum alloy pistons are used for highly rated engines running at higher piston heads. The coefficient of thermal expansion for aluminum is about 2.5 times the times that of the cast iron. Therefore, a greater clearance must be provided between the piston and the cylinder wall. Okay. In order to prevent seizing of the piston when engine runs continuously under heavy loads, but if excessive clearance is allowed, then the piston will develop piston slap while it is cold, and this tendency increases with wear. The less clearance between the piston and the cylinder wall will lead to seizing of the piston. Okay. The aluminum alloys used for pistons have high heat conductivity. Okay, high heat conductivity. Therefore, these pistons ensure high rate of heat transfer, and thus keeps down the maximum temperature difference between the center and edges of the piston head or crown. So these are the main parts in piston. The piston of internal combustion engine are usually of trunk type as shown here. Such pistons are open at bottom end and consists of the following parts, that is piston head or crown, piston barrel, piston rings, piston skid and piston pin. Okay, so these five are the important types. Here you can observe, this is the cross sectional view of the piston. Okay, cross sectional view of the piston. uh, so the piston is a disc which reciprocates within a cylinder. Within a cylinder, it is either moved by the fluid or it moves the fluid which enters the cylinder. The main function of piston of an internal combustion engine is to receive the impulse from the expanding gas and to transmit the energy to the crankshaft through connecting rod. Okay, the piston must also disperse a large amount of heat from the combustion chamber to the cylinder walls. Okay, so here in this condition, piston head or piston crown. The piston head or piston crown may be flat, convex, or this is the piston head or piston crown. This piston head or piston crown may be flat or convex or concave depending upon the design of combustion chamber. It withstand the pressure of the gas in the cylinder. Okay, piston barrel. Uh, Here you can observe here, this is a piston barrel. Okay, the length of this piston is called piston barrel. Okay, and piston rings. Here these are the piston grooves. Here we are inserting piston rings. Okay, piston rings are used to seal the cylinder in order to prevent leakage of the gas past the piston. Okay, here we are, these slots are called piston grooves. Here we are inserting piston rings and oil rings. Okay, here first three grooves are used for piston compression rings and last one is used for inserting oil or compression ring, oil or scraper rings. Okay, so these piston rings are used to seal the cylinder in order to prevent the leakage of the gas into the combustion chamber, gas into the crankcase. Okay, piston skid. This is the lower part of the piston rings. The lower part of the piston rings is called skid. Okay, the skid acts as a bearing for the side thrust of the connecting rod on the walls of the cylinder. Okay, and this horizontal rod is called a piston pin or gudgeon pin. It is used to connect the piston to the connecting rod. Okay, here you can observe here, this is the three-dimensional view of piston and its parts. This is a connecting rod. This is the small end of the small eye of the connecting rod. Okay, and here this is a piston pin or gudgeon pin. This is a piston with oil grooves and compression grooves. Okay, this is a piston pin hole. Okay, this is a crown or head of the piston. This is a oil ring or scraper ring. These two are the compression rings. Oil compression rings are piston rings. Okay, these three are the piston rings, but these two are compression rings. This one is oil oil ring or scraper rings. Okay, So here piston pin is used. This piston pin is used to connect the piston, and it is used to connect the piston and small eye of the connecting rod. Okay, so this piston pin is used to connect this piston and this connecting rod. Okay, here this hole and this hole, these two are same diameter. So by using this piston pin or gudgeon pin, or it also called breast pin, by using this pin we are connecting this piston and connecting rod. Okay, these oil rings or compression rings used to seal the cylinder in order to prevent the leakage of gases. Okay, now here you can observe the assemble of the piston and connecting rod. Here this is a piston, this is a piston pin, and this is a piston pin. Here these two are the circlips. This is a connecting rod, this is a small end connecting rod, this is a big end. Okay, big eye, this is a small eye. Okay, these two bolts are used to connect the two halves of the big ends. Okay, so here you can observe, here these grooves are oil grooves or compression grooves. Okay, piston rings, here we are inserting piston rings. Okay, this is the assemble of a piston pin, connecting rod, piston rings. Okay, now this is a cross sectional view of the piston. Okay, here this is the thickness of the piston. Okay, this is the piston pin, these two are circlips. Okay, now I am going to explain about piston parts, that is piston head or piston crown. Okay, the piston head or piston crown may be flat or convex or concave. Okay, convex or concave depending upon the design of combustion chamber. Okay, it withstands the pressure of gas in the cylinder. It should have adequate strength to withstand the straightening action due to pressure of explosion inside the engine cylinder, and it should dissipate the heat of combustion to the cylinder walls as quickly as possible. Okay, so this is the importance of piston head or piston crown. Okay, this piston, this is a crown or convex shape or concave shape, depend upon the type of combustion chamber. Okay, piston barrel, this is a piston barrel. From here to here, you can observe here, from here to here the distance is called piston barrel. It is a cylindrical portion of the piston. It contains piston rings, piston skirt, piston pin. Okay, so the length from here to here, okay, here you can observe here, the length from here to here is called a piston barrel. This piston barrel is in a cylindrical shape. Okay, piston rings, this is the shape of a piston ring. The piston rings are used to impart the necessary radial pressure to maintain the seal between the piston and the cylinder in the order to prevent leakage of gas past the piston into the crankcase. These are usually made of gray cast iron. Okay, these piston rings are made up of gray cast iron or alloy cast iron because of their good wearing properties, and also they retain spring characteristics even at high temperatures. The piston rings are of the following two types: compression rings or pressure rings, and second one is the oil control rings or oil scraper rings. Okay, these two are the piston rings. The compression rings or pressure rings are inserted in the grooves. Okay, here these are the piston grooves. Here we are inserting the piston rings. Okay, so we are inserting the piston rings at the grooves at the top portion of the piston, and maybe 3 to 7 in numbers. Okay, the number of piston rings depends upon the size of the piston. Okay, these rings also transfer heat from the piston to the cylinder liner and absorb some part of the piston fluctuations due to the side thrust. Okay, this last one is called oil groove. So oil control rings or oil scrapers are provided below the compression rings. Okay, these three are compression rings. This last one is oil ring. Okay, oil rings are provided below the compression rings. These rings provide a proper lubrication to the liner. Okay, by allowing sufficient oil to move up during upward stroke, and at the same time scrap the lubricating oil from the surface of the liner in order to minimize the flow of the oil into the combustion chamber. Okay, so these grooves are called oil grooves or piston grooves. Now another one is a piston skid. Okay, this is a piston skid. The lower portion of the piston rings is called skid. Okay, so the portion of the piston below the ring section is known as piston skid. Ring section means compression rings and oil rings. Okay, the skid acts as a bearing for the side thrust of the connecting rod on the walls of the cylinder. Piston pin. It is also called gudgeon pin or a wrist pin. It is used to connect the piston to the connecting rod. Okay, this is the position of the piston pin. Okay, these two verticals are called circlips. Circlips are used to fastening the piston pin in the piston. Okay, this is the cross-sectional view of the piston pin. This is the original shape of the piston pin. This piston pin is in a hollow portion. This it looks like a hollow sleeve. Okay, hollow sleeve or hollow pipe shape. Okay, so this is a cross-sectional view. Sectional view. This is a isometric view of the piston pin. Okay, what are the design considerations we have to consider in design of pistons? In design a piston for IC engine, the following points should be taken into consideration. First one is it should have enormous strength to withstand the high gas pressure and inertia forces. Second one, it should have minimum mass to minimize the inertia forces. Okay. Third point is it should form an effective gas and oil sealing of the cylinder. Fourth one is it should provide sufficient bearing area to prevent undue wear. It should disperse the heat of the combustion quickly to the cylinder walls. It should have high speed reciprocation without noise. It should be of a sufficient rigid construction to withstand thermal and mechanical distortion. It should have sufficient support for the piston pin. Okay, these eight are important considerations in the design of piston for IC engines. Okay, so pistons కి ఎక్కువ కంప్రెసివ్ లోడ్స్ని తట్టుకునే శక్తి అనేది ఉండాలండి. సో పిస్టన్స్ను మనం డిజైన్ చేసేటప్పుడు కంప్రెసివ్ లోడ్స్ని విత్ స్టాండ్ చేసుకోగలిగే కెపాసిటీ ఉండే విధంగా మనం డిజైన్ చేయాలి. అదేవిధంగా పిస్టన్ యొక్క బరువు అనేది, పిస్టన్ యొక్క వెయిట్ అనేది చాలా తక్కువ ఉండే విధంగా మనం డిజైన్ చేయాలి. ఎందుకంటే వెయిట్ ఎక్కువ ఉంటే, దానివల్ల వెయిట్ ఎక్కువ ఉండటం వల్ల మనకి ఇనర్షియా ఫోర్సెస్ అనేవి క్రియేట్ అవుతుంది. ఇనర్షియా అనేది బరువు ఎక్కువైతే ఇనర్షియా అనేది ఎక్కువైంది. సో ఇనర్షియా వల్ల మనకి అక్కడ వైబ్రేషన్స్ అనేవి క్రియేట్ అవుతాయి. సో వైబ్రేషన్స్ క్రియేట్ అయినాయి అంటే అక్కడ పిస్టన్కి అదే సిలిండర్కి మధ్య వైబ్రేషన్స్ క్రియేట్ అయ్యి అక్కడ సిలిండర్ లైనర్స్ని అక్కడ సర్ఫేస్కి మనకి అరిగిపోయే ఛాన్సెస్ ఉంటాయండి. సో ఇనర్షియా ఫోర్సెస్ అనేవి తగ్గించాలనుకుంటే పిస్టన్ యొక్క బరువు అనేది మనం తగ్గించాలి. సో పిస్టన్ యొక్క బరువు తగ్గించాలంటే మనం అల్యూమినియం లాంటి మెటల్స్ యూజ్ చేయడం వల్ల, అల్యూమినియం లాంటి లైట్ వెయిట్ అంటే డెన్సిటీ తక్కువ ఉన్న మెటీరియల్స్ యూజ్ చేయడం వల్ల మనకి ఆ వెయిట్ అనేది రెడ్యూస్ చేయొచ్చు. ఓకే అండి. సో అదేవిధంగా మనకి ఇక్కడ మనం యూజ్ చేసే పిస్టన్ రింగ్స్ అనేవి అక్కడ ఇందాక చెప్పుకున్నట్టుగా మనకి పర్ఫెక్ట్గా మన గ్యాసెస్ని లీక్ అవ్వకుండా ఎఫెక్టివ్గా అక్కడ అడ్డుకుంటూ ఉండాలి. అదేవిధంగా పర్ఫెక్ట్ ఆయిల్ సీల్స్గా మనకి అక్కడ యాక్ట్ అవుతూ ఉండాలి. అదేవిధంగా మనకి పిస్టన్కి బేరింగ్ లాగా, మన పిస్టన్ యొక్క సర్ఫేస్ అనేది సిలిండ్రికల్ షేప్లో ఉండేది కాబట్టి, రౌండ్గా ఉండేది కాబట్టి అది మనకి ఒక బేరింగ్ లాగా యాక్ట్ అవ్వాలి. ఆ పిస్టన్ యొక్క అవుట్ సైడ్ సర్ఫేస్ అనేది ఒక బేరింగ్ సర్ఫేస్కి ఎలాంటి అయితే ప్రాపర్టీ ఉండదు, స్మూత్గా ఉండి మనకి అక్కడ పైకి కింద పిస్టన్ మూవ్ అయ్యేటప్పుడు అప్వర్డ్ అండ్ డౌన్వర్డ్ డైరెక్షన్ మూవ్ అయ్యేటప్పుడు పిస్టన్ యొక్క సర్ఫేసెస్ అనేవి లైనర్ సర్ఫేసెస్ తగిలినప్పుడు అక్కడ బేరింగ్ ప్రాపర్టీ లాగా స్మూత్గా రన్ అయ్యే విధంగా ఉండాలండి. సో ఈ టైప్ ఆఫ్, అదేవిధంగా ఈ పిస్టన్కి హై స్పీడ్ రెసిప్రొకేషన్ ఉండే విధంగా ఉండాలి. అంటే ఎక్కువ స్పీడ్తో రెసిప్రొకేట్ అయ్యే విధంగా, రెసిప్రొకేట్ మోషన్ అంటే అప్వర్డ్ అండ్ డౌన్వర్డ్ డైరెక్షన్ అనేది ఎక్కువగా ఉండి నాయిస్ అనేది తక్కువ ఉండే విధంగా మనం డిజైన్ చేయాలి. ఓకే అండి. సో ఇవన్నీ చాలా ఇంపార్టెంట్. డిజైన్ చేసేటప్పుడు, పిస్టన్ డిజైన్ చేసేటప్పుడు ఇవన్నీ చాలా ఇంపార్టెంట్. మనం ఎక్కువగా కన్సిడర్ చేయాలి ఇవన్నీ కంపల్సరీ. ఓకే, ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఇక్కడ చూడండి, ఇంకొకటి మనకి పిస్టన్ అనేవి సింగిల్ సిలిండర్ ఇంజిన్స్లో వాడుతున్నామా, మల్టీ సిలిండర్ ఇంజిన్స్లో వాడుతున్నామా అనేది కూడా ఇక్కడ ఇంపార్టెంట్. సో మనకి ఇంజిన్ యొక్క సైజును బట్టి పిస్టన్ యొక్క సైజ్ అనేది మనకి చేంజ్ అవుతుంటుంది. ఓకే అండి. సో పిస్టన్ యొక్క సైజు చేంజ్ అయ్యే కొద్దీ దానికి యాడ్ చేసే పిస్టన్ రింగ్స్, ఆయిల్ రింగ్స్ కూడా చేంజ్ అవుతాయి. ఓకే అండి. అదేవిధంగా మనకి ఏ టైప్ ఆఫ్ ఇంజిన్స్లో వాడినా ఆ ఇంజిన్లో ఎంత టెంపరేచర్ అనేది డెవలప్ అవుతుంది, ఆ టెంపరేచర్ని తట్టుకునే మెటీరియల్ ఏది ఉంది, అల్యూమినియమా, క్యాస్ట్ ఐరన్నా, ఓకే అండి, లేదు ఎలై స్టీల్సా, లేదంటే అల్యూమినియం ఎలైస్ వాడాలా, ఏ టైప్ ఆఫ్ మెటీరియల్స్ వాడాలి అనేది కూడా ఇక్కడ ఇంపార్టెంట్ మనకి. ఓకే అండి. సో ఇవి ఎంతవరకు ఇంపార్టెంట్ మనకి పిస్టన్ యొక్క డిజైన్ చేసేటప్పుడు ఇవన్నీ చాలా ఇంపార్టెంట్. ఓకే అండి. ఓకే, these are the important formulas for designing of piston. In first step you have to design a piston head. Okay, so you have to identify the suitable thickness for piston heads. Okay, The design of a piston heads depends upon the on the basis of strength criteria as well as amount of heat transfer from piston surface to the surrounding surface. Okay, so it is first step. So design of a thickness of a piston head is the first step, and the second step is design of piston rings and cup. Okay, so it is the second step. In second step, you have to design a number of ribs, piston ribs required. Okay, and shape of and radius of the cup. Okay, in third step, you have to design the size of piston rings and number of piston rings. Okay, in third step, you have to design a number of piston rings required and as well as a number of oil rings required for piston. You have to design. In fourth step, you have to design piston barrel. You have to find the thickness of the piston barrel. Okay. In fifth step, you have to design a piston skirt. Okay. So in fifth step, you have to find the length of the piston skirt. Okay, and in sixth step, you have to find the dimensions or outside and outside diameter of the piston pin, outside and inside diameter of the piston pin. Okay, in sixth step, you have to design a proper size of the piston pin or gudgeon pin. Okay, so these six steps are used to design the piston head, piston barrels, piston rings, okay, piston pins. Okay, these six steps I will explain in next class. In next class, I will explain how to design a piston. Okay, by using these formulas. Okay, friends. Okay, friends. Thank you.